ocean has deadly lakes. Deep beneath the ocean's surface, far below where sunlight can reach, lies a world of silence and crushing pressure. Down here, the seafloor is not just mud and rock. In some places, it hides something far more dangerous. Submersibles moving through the darkness sometimes come across what looks like a calm lake resting on the ocean floor. Its surface is smooth and glassy, gently rippling as if moved by a breeze. But this is no lake of fresh water. It is a deadly trap. These strange features are called brine pools. They are some of the most dangerous natural environments on Earth. Any animal that swims into one is almost certain to die. Oxygen disappears. Toxic gases burn tissue. Extreme salt levels pull water out of living cells. And yet, around the edges of these deadly lakes, life still finds a way to survive. To understand how something so deadly can also support life, we must explore how brine pools form, why they kill, and what secrets they hold about Earth's past and possibly life beyond our planet. So join us on this incredible journey around nature. Brine pools are lakes of extremely salty water that sit on the seafloor. Unlike normal seawater, these pools contain salt levels 3 to 8 times higher than the surrounding ocean. Because of this, the water inside them is much heavier. It does not mix with the water above it. Instead, it stays trapped in low areas on the seafloor, forming a clear boundary called a halocline. This boundary looks like a shimmering surface, almost like oil floating on water. Submersibles can actually rest on it for a moment, as if landing on a liquid floor. When something disturbs it, waves ripple across the surface in a slow, ghostly motion. But the danger goes far beyond salt. Most brine pools contain no oxygen at all. They are filled with toxic chemicals like hydrogen sulfide, which smells like rotten eggs and is deadly to most animals, and methane, which can suffocate living creatures. Some brine pools are icy cold, matching the deep ocean around them. Others are incredibly hot, heated by volcanic activity beneath the seafloor. Some are small, only a few meters wide. Others stretch for many kilometers. They look calm and quiet, but they are some of the most hostile places on the planet. But how exactly are the brine pools formed? Let's find out. The story of brine pools begins millions of years ago. In many parts of the world, ancient seas once covered the land. Over time, these seas dried up, leaving behind thick layers of salt buried beneath the seafloor. These salt layers are called evaporates. As seawater slowly seeps down through cracks in the seabed, it dissolves this buried salt. The result is extremely salty water, much heavier than normal seawater. This brine slowly flows downward, collecting in deep depressions on the ocean floor, where it forms a pool. In places like the Gulf of Mexico, huge underground salt domes push upward, cracking the seabed and allowing brine to leak out. In the Red Sea, volcanic heat plays a major role. Hot fluids dissolve salt and create superheated brine that settles into deep basins. In the Mediterranean Sea, brine pools are leftovers from a time when the sea nearly dried out millions of years ago. These pools are not permanent or stable. Earthquakes, landslides, or volcanic activity can suddenly change them, releasing new brine or reshaping existing pools. Because of this, brine pools act like natural record keepers, storing layers of sediment that preserve ancient events. But that's not all. Crossing into a brine pool is almost always fatal. The moment an animal enters, the extreme salt concentration pulls water out of its cells. This causes tissues to collapse and fail. At the same time, the lack of oxygen quickly leads to suffocation. Hydrogen sulfide adds another layer of danger. It interferes with the body's ability to use oxygen, even if some is present. Methane can also displace oxygen and cause rapid death. Together, these factors create an environment where survival is nearly impossible. Fish, crabs, and eels often wander too close by accident. Once they cross the boundary, they become trapped. They sink into the brine and die within minutes. Their bodies do not decay like normal remains. Instead, the brine preserves them. Over time, rings of dead animals build up around the edges of the pool, creating underwater graveyards. One famous example is the hot tub of despair in the Gulf of Mexico. This warm, toxic brine pool has claimed countless animals whose preserved remains still rest along its rim. And here comes the shocker. Despite their deadly nature, brine pools are not lifeless. Along the thin boundary where normal seawater meets brine, life flourishes in strange and unexpected ways. Microbes form thick mats along the edges. These bacteria and archaea do not rely on sunlight. Instead, they use chemicals like hydrogen sulfide and methane for energy. This process, called chemosynthesis, allows life to exist in total darkness. Larger animals depend on these microbes. Mussels, worms, and shrimp form partnerships with bacteria that live inside their bodies. The bacteria provide food, and the animals provide shelter. Predators patrol the edges, feeding on animals that become stunned by the toxic water, but do not die immediately. Some of the microbes found here can survive extreme heat, pressure, and salt. Scientists study them for medical and industrial uses, including new antibiotics and enzymes that remain stable in harsh conditions. Some brine pools are especially well known because they are large, extreme, or scientifically important. One of the most famous is the Orca Basin in the Gulf of Mexico. This massive brine pool covers more than 100 square kilometers, making it one of the largest ever discovered. Its water is extremely salty and completely without oxygen. Because nothing disturbs the bottom, layers of sediment settle slowly and remain perfectly preserved. These layers act like pages in a history book, recording thousands of years of environmental change. Scientists study them to learn how ocean conditions, climate, and even nearby river systems have changed over time. The Red Sea contains some of the hottest and most unusual brine pools on Earth. Many of them are heated by volcanic activity deep below the seafloor. In recent years, scientists discovered new brine pools near the Gulf of Aqaba. These pools are special because they are much closer to shore and shallower than most others. Even more important, their sediments preserve clear records of earthquakes, floods, and tsunamis from the past 1,000 years. Each layer tells a story of a sudden disaster, followed by long periods of calm. These records help scientists better understand how often major natural events occur in this region. In the Mediterranean Sea, several deep hypersaline basins stand out for their extreme conditions. Pools such as Urania and l'Atalante are among the most toxic marine environments ever found. They are filled with hydrogen sulfide and contain no oxygen at all. Any animal that enters them quickly dies. Yet even here, life survives at the edges. Unique microbes live along the boundary between normal seawater and brine. These organisms exist nowhere else on Earth and help scientists understand the limits of life. And this is where it gets really interesting. Brine pools are more than deadly underwater lakes. They are powerful scientific tools. Because their sediments are undisturbed, they preserve clear records of Earth's past. Scientists use them to study climate change, volcanic eruptions, ocean chemistry, and natural disasters stretching back thousands of years. They are also important for the search for life beyond Earth. Moons like Europa and Enceladus may have salty oceans hidden beneath thick ice. If life can survive in Earth's toxic brine pools, it raises the possibility that life could exist in similar environments elsewhere in the solar system. Studying brine pools is extremely challenging. The pressure is intense, and the brine can damage metal, sensors, and electronics. One small mistake can end a mission. Scientists rely on robotic submersibles and careful planning to avoid disturbing these fragile environments. As technology improves, researchers hope to explore deeper and more safely. With each mission, they uncover more hidden brine pools and learn more about the strange, dangerous and fascinating world at the bottom of the ocean. Brine pools are one of the ocean's greatest contradictions. They are places of death that preserve life. They destroy almost everything that enters, yet support ecosystems at their edges. They look calm and peaceful, but they are among the most hostile places on Earth. They remind us how little we truly know about the deep ocean. Most of it remains unexplored, hiding dangers and wonders beyond imagination. As we continue to search the depths, brine pools offer a glimpse into Earth's past and perhaps into the future of life beyond our world. What other deadly environments might still be waiting to be discovered beneath the waves? And what kinds of life could survive there? Let us know what you think of these questions in the comments. Don't forget to like, share, and subscribe, and check out the next video popping up on your screen now. You will like it.